Hello everybody, we're getting ready to do 5.3 complex numbers of SAT Math Level 1 Prep. Email me here for information. 5.3 complex numbers, we got 14 points here of notes and we have a 48-point skill sheet. Contact me for skill sheets. I can provide grading and tutoring on skill sheets. Our classwork is called a skill sheet, and then notes. I got note-taking guides as well. I can provide. Email me. Overview here. The imaginary unit I is defined such that I squared equals -1, so that I equals the square root of -1. An imaginary number is product of non-zero real and imaginary unit I, as in 2. Complex numbers, when imaginary numbers combine with a real number, as in 3 plus 2i, the result is called a conjugate, is what it's called. That has the form of a plus bi, where a and b are real numbers, and I equals -1. Since any real number a can be written in the form of a plus 0 times I, the set of complex numbers includes a set of real numbers. For example, 5 is a complex number since 5 equals 5 plus 0 times I. Properties of complex numbers. All the properties of arithmetic that work for reals will also hold for complex numbers. When performing arithmetic operations with complex numbers, terms involving I are treated as if they are monomials. So 3i plus 5i, then here are examples here of arithmetic operations with imaginaries. Then we have the same exponent rules here. And then same here again, product of power property. To add or subtract complexes of the form like this, the conjugated complex number, combine real parts, then combine imaginary parts. Now here's an example here, 2 plus 3i plus 4 minus 5i, so we have 2 plus 4, we combine the two real numbers, and then we combine imaginaries and we come up with this here. So same thing here, we add the reals and then we combine the imaginaries and then we put them together in this. Same thing here. 2 times square root of 9 times square root of 1. 8i plus 6i. So this would be I here, this would be I here. See 8i and then 2 times the square root of 9 would be 3, would be 6. Then we can combine those to 14i. Then same thing here, we're going to factor out stuff underneath our radical, use the radical property of division, and the same thing over here. We factor out certain forms for our radicals. 5 times 2i plus 12 times 2i. And then we combine these two here, 17 times the radical 2i. To multiply complex numbers of the form a plus bi, treat the complex numbers as binomials, and then use the FOIL method. So we have this here. We have this statement here, and that's going to be FOILed. First, outer, inner, latter. So, and then once we have this factored out here, then we can multiply out and then put them in this fashion here. 15 minus 12i plus 10i minus 8i squared here. And then we're getting ready to combine like terms here. 15 minus 2i minus 8 times -1. 15 minus 2i, here's our 2i, and then minus 8 times I squared would be -1, so it'd be a minus and 8 times a -1. That's where that comes from. And then we further combine and we have 23 minus 2i. So simplifying higher powers of I, first two powers of I are worth remembering. So you can simplify a higher power of I by rewriting it so that it is expressed in terms of power of I squared. So I to the 0 is 1, I to the first power is I squared is negative 1, and then I cubed would be negative I. Then I 35th equals I 34 times I. Factor out from I 35 so that one of its factors has the greatest even exponent. Then rewrite I to the 34th as a power of I squared. I squared to the 17th power times I would be the same expression there. And then this is negative 1 to the 17th power times I, which would be negative I right here. Because this will be a negative here, it's to an odd power. Okay, to illustrate further here, we have I to the 82nd power. How would we conjugate that? So we factor out an I squared, and that would be to the 41st power there. And then I squared would be negative 1 to the 41st power. And when negative 1 is to an odd power, it's negative 1. Now here, I to the 12th to I to the first power. This can become I squared to the 6th power, which is negative 1 to the 6th power, which will be 1 times I, which is I. So complex conjugates, a plus or minus bi. The numbers 3 plus 2i and 3 minus 2i are complex conjugates. Pair of complex numbers having the form a plus bi and a minus b are complex conjugates. The sum and products of a pair of complex conjugates are always positive real numbers. For example, 3 plus 2i, 3 minus 2i equal 9 minus 6i plus 6i minus 4i squared. This equals 9 minus 4 times negative 1. Minus 4 times negative 1 here. 9 plus 4 equals 18. And then which of the following complex numbers is equivalent to 8 minus 4i over 5 plus 3i? No, I equals the square root of negative 1. So which of the following complex numbers here is equivalent to this here? So in order to produce an equivalent fraction with a real number in the denominator, multiply the numerator and denominator by 5 minus 3i, the complex conjugate of this. So it is the kind of like the multiplicative inverse would be one way of putting it, of 5 plus 3i. So if we do that here, 5 minus 3i over 5 minus 3i, we get this expression here is what we get when we FOIL these two binomials up here. So we get this in the bottom. We do the same thing down here, 25 minus 9i squared. This becomes 25 plus 9, and then up here we have this. Further simplifying, this becomes 34. This becomes 40 minus 44i minus 12. So these are combined. And then this becomes a negative 1, negative 12 here, negative 12. And then 40, and then further combining, we get this 28 minus 44i over 34. And then we can factor out 2, and it comes 14 minus 22i, which is b right here. Okay, for further lessons, PowerPoints, animated PowerPoints that you can use at your own speed with note-taking guides, etc., email me here, and I'll fix you up. Thank you.